In this video, we'll use sports data not to decide who is better, and not to explain why a team wins. Instead, we'll focus on something much more important for the SAT. What the data actually shows, and what it does not show. Sports are a perfect example, because highlights, single games, and averages can easily mislead us. Just like in the SAT, the strongest looking claim is often not the correct one. Our goal here is simple: to practice careful reasoning, not bold conclusions. Before we move on, let's slow down and carefully observe what this graph is actually showing. Each bar shows goals scored in one game. Player A and Player B each played 10 games. So we're looking at 10 game results for each player, side by side. When we add up the goals across those 10 games and divide by 10, both players end up with the same average goals per game. At first glance, that might make the two players seem similar. But now, instead of focusing on the average, look at how the results are spread across individual games. Player A's bars are all the same height. This means Player A scored the same number of goals in every game. Player B's bars go up and down. Some games have more goals, and some have fewer. The game-by-game results are not the same. This brings us to a key idea for the SAT. Even when two players share the same average, their distributions can look very different. From the data, we can see a difference in patterns across games. But from the average alone, we still cannot make any strong conclusions. Now let's be very clear about what this data can tell us, and what it cannot tell us. From the graph, we can say that both players have the same average goals per game. We can also say that their game-by-game patterns are different. The distributions do not look the same. However, there are several things we still cannot say. We cannot say that one player is better than the other. We cannot say that one player is more reliable or more consistent. And we cannot use this data alone to predict how either player will perform in future games. This is exactly the kind of distinction the SAT expects you to make. The correct answer is often the one that says only what the data clearly supports, and nothing more. Now let's take a closer look at this example. On the screen, you see goal totals across 10 different games. Most of the games look fairly similar, but one game stands out as more impressive than the others. At first glance, that single game can easily catch our attention. It looks strong, and it feels meaningful. However, we need to be careful. A single game like this may be an outlier. When we focus on just one game, we do not have enough information to identify a long-term pattern. This one result could be unusual, or it could simply be part of normal variation. To evaluate performance more carefully, we need to look at multiple games together, not just one standout result. This is an important idea for the SAT. One impressive data point alone does not establish a trend. Now let's look at another common situation in data analysis. On the screen, the data is divided into a before period and an after period. At first glance, it really does look like performance improves in the second half. After the midpoint, the bars are generally higher, and that makes it tempting to say the player performed better after this point. However, we need to slow down here. A before and after comparison like this does not prove that performance truly improved. The sample size is small, and there is still noticeable variation both before and after the dividing line. Some higher games appear earlier, and some lower games still appear later. Without additional evidence, we cannot tell whether this difference is meaningful or simply due to chance. This is a key idea for the SAT. A visual change between before and after may look convincing, but it does not demonstrate a real or significant effect on its own. Now let's look at one of the most important ideas in data analysis. On the screen, we see a relationship between two variables, goals scored and games won. As goals scored increase, the number of games won also tends to increase. Because these two variables move together, we say they are correlated. However, this is where we must be careful. Correlation alone does not prove causation. While scoring more goals may help teams win, this data by itself does not show that goals are the only reason for winning. Other factors could also affect results, such as defense, teamwork, or strategy. This distinction is critical for the SAT. When two variables are correlated, it can look convincing, but that relationship alone does not establish a cause and effect connection. Now let's take a moment to step back and review what we've learned from these sports examples. Throughout this video, we did not focus on calculations. Instead, we focused on how to reason carefully with data. First, we saw that averages alone do not tell the full story. Two players or teams can have the same average, yet very different game-by-game results. Next, we learned that one impressive game does not establish a trend. A single highlight can be memorable, but it does not provide enough evidence to draw long-term conclusions. We also examined before and after comparisons. Even when performance appears to change, that visual difference by itself does not prove a real or meaningful improvement. Finally, we looked at correlation and causation. When two variables move together, the relationship can look convincing. But correlation alone does not demonstrate cause and effect. These ideas are at the heart of SAT data analysis. Strong conclusions require sufficient evidence, careful reasoning, and a willingness to avoid jumping to conclusions. Whether the context is business, sports, or any other real-world situation, the same reasoning principles apply. As you prepare for the SAT, remember that the correct answer is often the one that makes the weakest claim. Careful reasoning means respecting what the data shows, and just as importantly, recognizing what it does not show.